Hi guys. Today we're gonna be talking about containers. Basically, what containers are, what exactly do they do, how to use them, and this time we will be focusing specifically on Docker, but we've got like all so many other options out there in the market. All right. The I'm not sure about like the quality of the audio because I'm recording this on my Linux PC, and there's like some sort of static noise. I don't know if it's gonna reflect like in the final recording, but you just have to bear with me. All right. We're gonna be first. So the first thing that comes to mind, right? You probably we've talked a bit about containers, and this wouldn't be like the first time you were hearing about it, right? But when we talk about containers, so just to take a step backward, I know we've done like the basics of Docker, but to take a step backward, and we need to ask ourselves, right, what a container is, and to really understand what a container is, and to understand like the particular problem it solves, and why it's introduced in the first places, we actually need to work back a little bit back in time. So like back in the day, right, when you build your application, like in our case, we're building like a back end, it would be like a front end or something. We will take that, we'll go get like a physical server, right? We'll get like a physical server, and we will put our application there, right? We put our application in the physical server. By Because we have a physical server, right, we need all like the resources to make sure like the server works properly, right? So we need electricity, we need to connect that server to the internet. We probably even need to hire like a Linux, maybe a system admin, to come manage like the entire server if we can't do it ourselves, right? And so people started looking, okay, how do we really like optimize like this process, right? Maybe a big company might be able to afford to buy like a physical machine, a big physical machine, and provision like all the resources needed to manage and make sure the physical machine works with the human resources, every other thing that's needed for that to work properly, right? But imagine like maybe like a smaller company, or someone you have a startup today, right? You can go and start buying a big server and start provisioning like everything, start hiring like a system admin. Like that's very expensive. So because of that, right, the whole concept of VMs or virtual machines came up, and I'm very sure like this isn't the first time you're hearing a virtual machine. So if there's I'm very sure you've used some of this. You've used this virtual box, right? So virtual boxes as a VM, you've probably used it on Windows, or that you can use that to okay, the website isn't working, right? You can use that to basically like provision VM. So what's a VM? So a VM is kind of think of it uh, like another what's the word? Like another kind of machine, another kind of like a way of partitioning like the PC, right? You're partitioning your PC, so you have like multiple kind of like, so virtual is something that isn't really real, right? So you would have like multiple like boxes of machines inside that one machine. So if we take for example my laptop now, assuming I'm running a Windows 10 laptop, I can have like maybe 3 or 4, 5, 6 VMs of Ubuntu running inside like those VMs, and then I'm very sure that's not a new concept to so many people here. So you can basically use and you can basically use the VM like you're using a separate machine, right? So the VM is the host machine. So there's like the host machine, that the main machine, and you have like a VM, right? So the host machine allocates like resources to the VM, and if anything by any chance happens to one of the VMs, or something dies or something happens, right? It doesn't. Maybe the VM crashes. The VM just crashes, and nothing happens to like the host machine, right? There's like isolation, right? And like because of VMs, the whole concept of VMs, that's what gave birth to what we know today as like the public cloud, right? So so think of it this way. Let's say I have like a very big physical server, and maybe I'm just using like maybe for my entire app, I'm using like just 10% of its capacity, right? I can create VMs and then sell those VMs to you for you also to come host your app in there, right? That's what the likes of AWS, the EC2, and Google Compute, Cloud Compute Engine, that's what they all do, right? And VMs give birth to like the public cloud as we know today. In fact, according to the story, they would say that that AWS got so good at doing all the stuff, and then they figured out, okay, let's Amazon got so good at doing all this stuff, and then they figured out, okay, let's make a business out of this, and that's how AWS was born, right? So uh, that's uh, that's it for VMs. So VMs are basically like a way of achieving like isolation, right? But at the OS level. So I don't want to go into like the specifics of this. If I remember right, there's like an hypervisor in between like the operating system, right? That would allow like now have like multiple guest operating system on the main operating system, but isolated from each other. All right. So what's a container? So if you've ever tried to install Windows before, right, or install Linux or any operating system, you see how long it takes. You see how much time it takes to provision like those resources, right? Right. You see how if you've used VirtualBox, right, once you turn on your VirtualBox, your PC starts screaming. By the time you have like a couple of VMs, right? So achieving isolation by which at the OS level, that at like replicating like a new OS, right, is very expensive and resource intensive, right? So people figured out, okay, there should be like a more optimized way of trying to achieve what we achieve with with a VM, right? So and that's where the concept of containers come in. So containers kind of try to achieve the goal of a VM, but in a far much more simpler way, right? So rather than like bootstrapping like an entire new operating system, your way to think of containers kind of like a box, like a box where you can have like isolated processes, right? And it's just a way it's a way to achieve isolated processes, and like under the hood, right, containers take advantage of just a few. I can't speak for like how they work in other operating system, but particularly like for Linux, right? I think for other operating system too, there's at least for Docker, there's like a Docker desktop, which is sort of like a VM, right? But for Linux, right, what happens is that containers are just like putting together like a few features of the Linux kernel to achieve this isolation. So if you're curious about that, you can go dig into like a change root, or some people call it char root. Um, you have like namespaces, I think process namespaces, and networking file system namespaces and networking namespaces. So these are basically ways that to achieve this isolation. And when you think of isolation, right, or from just think from like if you want to have like some sort of like enclosed space, right? How would you try to achieve this, right? You want to isolate like the processes, right? So you don't want to imagine like if we have like on the same we have like a VM or a container or anything that we try to achieve isolation with, right? We have two of them on the same machine, right? And we're on a server, and then we rented out this servers to competitors, right? If a competitor inside one VM can see what's going on in the other person's VM, or can assess what's going on in the other person's VM, right? That's a problem, right? So basically, we we try to achieve like this. Containers try to achieve this isolation by using like a few features of the Linux kernel that do this, right? And by bringing them all together, we basically we have like we have a container. So they are different. They're different like what I say types, not types. The different kinds of containers, right? Like you have like Docker. There's like Podman. I think there's another one like called I think Rocket. So there are a couple of them, but Docker is like the most popular and the most widely used one today, right? It's the focus of we're gonna like focus throughout in Docker, but just know that you might stumble into containers somewhere, and that might not be Docker, but Docker is like the most popular one. All right, so uh, so I think I was just this is just an example of a this is an example of a VM. So Vagrant is this thing that's just used to. So we've already played around with Docker, so I'm very sure like you guys know how to use. You're familiar with like the basics of Docker, but this is sort of like a refresher, right? So so Vagrant is this thing that gives you like you see the way you do Docker up, Docker, Docker, Docker up, and all of that. That sort of convenience for you to start, to you to manage like your VMs, right? Vagrant brings all that convenience. So with Vagrant, okay, I already have a Vagrant init file here, so that wouldn't even work. I just have to do Vagrant, Vagrant up, and then Vagrant SSH. And yep, that should be it. All right, so with this, so Vagrant is just a thing for like conveniently like managing. Okay, I didn't know this has to go. I'm just gonna stop this. But if you're curious, you can just go look into it. So it's a very convenient way for you to bring up VMs, start and stop them. So I personally I use Vagrant for like just playing around with things. Maybe if I want to try out like maybe like I want to learn like something that if I do it on my main Linux system, I could maybe learn something. So it's sort of like I use it like sort of like a playground for like learning about like Linux stuff and doing stuff in a sort of isolated environment, right? Since it's a VM, whatever I do at the end, it won't affect like my host laptop, right? I can just bring it down when I'm done. All right. So, but going back to the main thing of our focus today, right? Which is which is Docker, right? So Docker is just basically like a tool for helping you easily manage containers, right? So the much of what Docker does, right? You can do it by hand, right? So for example, say like if when you start up a Docker container, right? You start up a Docker container, right? You have like an isolated environment. Or that isolation, maybe to isolate the file system, you can do that like manually if you want to do it, right? To isolate like the processes, you can do that if you want to do that. To isolate the networking, you can do that with if you want to. You can do that manually if you want to do that, right? I've done it before on Linux, and it's a whole long process. We're not going to focus on that, but the point I'm trying to drive is that you can actually do much of the stuff that Docker is doing for you by hand if you want to do that by hand, but it's a whole long process, right? People just want like a very clean like interface to work with. No one wants to go and be messing around with like Linux commands when you're trying to deploy your application. All right, so a couple of things about Docker. So the first thing that you would probably stumble on when you're trying to use Docker is, so for example, when we say Docker run, I'm thinking of, let's say Docker run Redis, right? Really hope my internet works. Right. So the very first thing, when we talk about when we're talking about Docker, when we talk is an image, right? So basically, what's an image, right? So an image is basically like taking like the state of a container, right? At the current state of a container, just basically like zipping it, right? Taking that state, freezing it, and zipping it, right? That way you can send like you can basically send like that container right to someone, right? I don't know if that's a good explanation, but that's basically what an image is, right? Just like sort of like taking like the current state of a container that's currently running, like zipping it and then sending it, zipping it, and then you have like an actual physical thing, right? And that's the thing you can send to someone, and the person just has to unzip it and continue like using it, right? And that's basically what Docker does under the hood, right? So when you create an image, Docker does everything, zips the image, and you can push the image up to the registry, and we'll talk about that in a bit. And also another person can pull it, and Docker will extract like the image, and then basically like run the image and get back the same container, right? All right. So yeah. So the first thing, that's basically an image, right? So if we go, the next thing we have to talk about is basically is this thing called Docker Hub. So Docker Hub is a container registry, right? Think of a container registry like I don't know, like npm, right? Yeah, exactly. That's what exactly it is. It's like an npm, but for like keeping like your Docker images, right? So you have like all kind of images here. Like you can see, there's like an official Python image, there's a Hello World, there's a MariaDB, there's traffic, there's Ubuntu. Anything you probably want to do, there's like an image for it. If you come here and search for like maybe like Node, for example, right? You would see there's the official Node image, right? If you come and search for Mongo, Mongo, right? There's there's images for almost everything you want to do, right? So that's basically Docker Hub for you. So you can store like your images here, right? So this is where think of it as an npm, right? So when you do npm install, you pull something from like npm like remote registry, right? So it's the same thing here. So it's a registry or repository for keeping like Docker images, all right? So now when we do npm, it's because I have Redis locally, so I want to think of a good image. Let's do a Docker pull hello world, right? So when you do this, you can, so there's a let's go to this image, and actually let's go search for hello world. Actually, I saw it on the homepage. Oh, okay, it's not here. All right, so yeah, but basically, right, you can, images are basically here, right? So anything that's on this repository, right, you can do Docker pull from this, and you can also do like your own private repository or even a local repository, but that's like beyond like the scope of this, right? Most people would push to like a public repository. The very popular one is like Docker Hub, right? And you can come here and you can pull like this specific image, right? You can also push your images. If you have like your own custom images you want to push to like Docker Hub, you can also do that. I'm sure you've seen that in the other resources I sent to you. You can play around. You can play around with that. But basically, so now you have, for you to run an image, you can always like just for you to first use an image, you have to first pull that image from the repository, right? So also think of this like a Git. So now we can just simply do Docker run hello world, right? So this will run. We can now run like this image, all right? So what's the command? So we can have like when you pull an image, right? That image initially lives on like a remote repository, right? When you do Docker pull, right? You pull that image from the remote registry or the remote repository down to your local repository, right? So you can see the list of images you have, both the ones you built locally and the ones you pulled from a remote registry. So you can do that by Docker image ls, right? You can either do Docker image ls, or you can do, I think, Docker images, both the same thing, right? And this will show you like all the images. So I have a couple of images. I can't remember what some of these are, but yeah. All right. So this is basically that's basically Docker images in a wrap. So the next thing we're going to talk about is so we've talked about we're all Node.js developers, right? So we kind of want to talk about like Docker, but in the context of Node.js, because we will be using like Docker a lot to build our Node.js apps. All right. So All right, so when we go and search for node in the in Docker Hub, right, would see like this is the official this is the official what's the word this is the official Node.js image, right? So be a couple of like other when we will talk about this, we'll talk about all of this in a bit, but we'll talk about like tags and all of this in a bit, but this is the official image, right? So when you do Docker pull, I don't know if I have that image. I don't know if I have that image. Docker images. I think I should grab I node. Right. Alright. That's a very big image, and I'm using like mobile data, and I don't want to. My fiber internet is very slow, and I don't want to pull. But when you do Docker pull node, right? You can pull like the official Okay, I think I. Oh, okay, that's interesting. Oh yeah, I have it here. Right, you pull like the official image. All right, so you can also inspect. You can do Docker inspect. You can inspect. You can inspect like an image, right? So you can inspect node. Let's inspect node latest. Right, you can inspect an image. You can see the details of an image, like the size of the image, the OS, things like details about like the image, right? You can do that, and also you can also let's see, you can also so let's do something. So when I say Docker run node, right, I can also like add an extra command. For example, I can say this should right. So you can put like a when you attach, you can attach a command that you want to be run like after. So like in here I'm doing ls. So remember we said like this is a container, right? So you can SSH into a container. It's an all totally isolated environment, right? So you see how like the file directory here, this is like the default like Linux like a file directory, right? So you can do all of this, right? All right. So what's the next thing we want to talk about? All right. So let's see which of the images. We want images an image that doesn't have to. Okay. So let's say Docker. Let's run Redis. You can also run a container in a detached mode, right? So if I do this, right, this will run like the container in the background, right? So this should be just to be sure, Docker. I think it's the Docker run detached. It's the Redis. So I think the full meaning is so. And another thing with these flags, right? When you in most tools, right? The way like the syntax for the flag is if you put the double what's this thing called again? Double hyphen, you'd have to type in the full thing, right? So in this our case, we'll say Docker run detached Redis. I think this is detached. Yeah. All right. So detach basically runs it like in the background, right? So if I do so how do you see like the containers that are running, right? You see the containers that are running by saying like docker ps or docker, I think docker container ls. Yeah, they both the same thing, right? So you can see this container Redis, is running, right? And it was started when it was created 19 seconds ago, right? And we can also we can Docker, we can basically I'm just gonna use the container ID. We can let's see, yeah. So we can what's the word, like go into like the container, right? So this is like the Redis container now currently running, right? So I think if I do this Redis CLI, this should work, right? So now we have this is this is a this is a container currently running in Redis. So if I'm sure I killed my local Redis, right? You see my local Redis is dead, right? But the one inside the container is working, right? So this is like a totally like a isolated environment, right? So a container basically has like everything, all the dependencies from like all like the OS dependencies and every other thing that's needed like to run, right? So it's a totally like isolated like an environment, right, on its own. All right. So this is how we've seen how we can basically like open like an interactive shell in the container So I think yep. All right. So we've so the previous command I did, this thing is a short form for the long form for it. I think is interactive, if I'm not mistaken. I'd have to like confirm the documentation to be sure. Interactive. Oh, okay, I spelled interactive wrongly. So, yep, yeah, should be interactive. So you can basically go execute like a command on a running container, right? So in our case, the command we're executing is like bash, right? We want to use like the bash shell. All right, so we've talked about like a couple of things, but these are just like background information, right? Trying to introduce us to like a good framework for thinking about like containers, right? All right, so if we see it like containers are a way of achieving isolation, right? So means that every other thing, the container is isolated, right? Any resource that we need our container to access, we have to find a way to like we have to figure out like how to make our container be able to like access that resource. All right, so the next thing I'm going to talk about is Docker files, right? And basically, what's a Docker file? I'm just gonna do this Docker file. I'll just pull up the documentation. But basically, like a Docker file, right, is a think of it as a template or a list of instructions, right? A list of instructions on how we should build our image, right? So everything you need, like for example, let's assume, think of a typical way. If I want to use Node.js on my system, right, I have to first install Ubuntu, and then when I install Ubuntu, I have to now go and install Node and install npm, and then all of that, right? So you basically will take all that process, all the things, that's all the instructions that's needed to run your application, and you will take that and encode them into like some sort of instructions for Docker, right? And Docker would use this in building the image for you to run your application workload. All right, so let's start with 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 a, with a let's call this Docker example, right? So let's make a new directory called Docker example. All right, so call this Docker example. So how do we create like a Docker file, right? The documentation is very comprehensive, but essentially you just have to put like a list of basically what you want to do. So I'm going to kind of use like this opportunity to talk about like a couple Docker in the context of Node.js, right? So when you look at like the Node official image, right? there are these things called tags, and we'll talk about them. But basically, these tags kind of talk about like sort of how is this thing built from. So Buster, Slim, and all this Slim. I think Slim is basically um, Slim is basically I think it's a version of Ubuntu that doesn't have like that just has like the very bare minimum of stuff that's needed to run, right? So you because in a container you don't need like there's so many things in this. For example, Ubuntu by default comes with Python, right? You don't need Python running inside your container, right? You're just running a simple Node.js app, right? So you don't need any of that. All right. So what's a Docker image, right? We've talked about like what a Docker image. We've talked about what a Docker file is. So we're just gonna write one. We're going to write one, right? So let's make a very simple. Let's make a very simple. A simple. Let me use VS Code. I'm trying to reduce how much VS Code I use because this is a very. The system isn't built for like heavy workload, and I already have OBS running. Alright, let me see how much of my file system, my CPU is being used. Alright. So all Docker files basically have this Docker file extension, right? So there has to be like a Docker file. Right, so I'm just gonna touch while I'm waiting for VS Code to shenanigans to, okay, VS Code is on. So I'm just gonna touch a Docker file. Alright, so I want the auto completion, so you can see already VS Code can tell us, right, that this is a Docker file. Alright, so we need like some sort of, so in Docker you can build stuff, you can build like your image from another image, right? So for example, if you're building like a Node.js image, you probably want to build from, if you're building a Node.js image from scratch, right? You don't want to build like from scratch, right? You're just concerned with the application parts, the stuff related to your own application, right? To be specific, right? So you should use the official Node.js images rather than trying to build like your own. Like in this, you can see how like this is an image that's been built from Alpine, right? Alpine Linux. We'll talk about what Alpine is in a bit, but like this is what and you can see like this can get like this is like OS level stuff and can get like very complex if you don't know what you're doing. So there are people who are experts in making like these images, right? So just all you just have to do is use like the base image they provide, except you have a very custom scenario, which is very unlikely. All right. So now you want to say what's the latest, what's the image, what's the base image you're building from, right? So what's the latest what's the latest version for LTS for Node.js? Should be 16 if I'm not mistaken, right? Yeah, it should be 16, right? So we can say let's build our this thing from Node 16, right? And we will say from Node 16. All right. So then the next thing we're gonna do is basically I'm gonna talk a bit about like, so actually I can just talk about it now, right? So what this thing is, right? So tags are basically like a way for you to version things in Node.js, right? So I mean in Docker, right? So in this case we can see like we're versioning this to 16, right? So isn't like strict like npm semantic versioning or anything, right? Where you have to like follow like a very specific pattern, right? You can choose to like name like the versions for your tag how you prefer. So if we go back to Docker Hub, right? If we go back to Docker Hub, you will see like some of the names of the tags on the names are like some of them are Node something, Bosta, Slim, yeah, yeah. So it's up to your discretion to how you choose to like put these tags, right? But the way these guys did it, they have like a rationale for how this is uh, how this is is done. So basically, Bosta, yeah, I think Bosta here refers to Ubuntu. It refers to Ubuntu, but like a slimmer version of Ubuntu that doesn't have like all the unnecessary stuff, right? And you then Bullseye, yeah, I think refers to Debian, if I'm not mistaken, right? So Bullseye, I think, yeah, Bullseye refers to like Debian. But for most people, you would see most people using Alpine Linux. And let me just talk about in a bit what Alpine Linux is, because most Docker images for Node.js, you would say all use Alpine, right? So Alpine is basically, I think, Alpine, yeah, Alpine Linux. What did I? No, not that. Uh, Alpine Linux. Right, Alpine Linux is like a very small distribution of Linux that's basically you can that's basically used for like running like your application workloads, right? So take for example like Ubuntu. Ubuntu has so many things, right? So there's something called, I think it's called GNU, right? So GNU is like a collection of like open source programs, right? That basically like the likes of the Debians, the Ubuntu. I think they use this, right? But I think Alpine Linux doesn't have this. Alpine Linux uses something called BusyBox, right? That basically has like the very basic things you need to run your application workloads, right? And if you think of this, right, because you have like the dependencies are very few, right? The security vulnerabilities become also very low, right? Because you have very few dependencies, so you don't have so many things to worry about. Any other thing you need, any extra thing you need, you have to add them by yourself, right? So because it is small and very simple, it's very secure, and like you don't have to like worry about you don't have to worry about so many things from a security perspective. I think this BusyBox thing is what also works on I think Androids and the rest, because those are also like they kind of use Linux underneath, right? But it's a very small and lightweight distribution. So you see people really use this a lot for um, for building their images, right? So I think I'm gonna use, because I'm gonna use Node 16 Alpine because I think I have the image, and I don't want to Docker images. Don't want to. Yeah, let's see. Alpine. Do I have 16 Alpine? 12 Alpine, 17 Alpine. Alright, so we're gonna do 17 Alpine because I don't want to pull a new image. Actually, let's, yeah, I think, alright. So that's the first thing we do, right? So the next thing we wanna do is we wanna so let's create a very simple like HTTP server, right? So we're gonna just HTTP, right? So we're gonna require this is the inbuilt HTTP model, right? With Node, right? All right. So we're gonna say HTTP dot it should be a create server method, right? And this takes in a callback. This takes in a callback function that takes in requests and response. All right. So we can just put a console.log here, and we say we can say request received, right? And yeah, we can reply, we can give a response of response.end. We can say hello world, right? And we can return this back as a string, right? So we can tag a .listen method, and then we can listen on port 3000. And we can say it's console log something like server started on port 3000. All right. So if we let's see, if we run this node index.js, right, tells us server started on port 3000, right? And we can just call localhost 3000. I think this should, yeah, this gives us hello world back. All right. So let's attempt to dockerize like this very simple application, right? So the first thing we're gonna do is now we've brought in our base image, that's Node, right? So Node basically has everything for us to work with, right? So the next thing we're gonna do is we're gonna copy, right? We're gonna copy everything we need, right, from here, right, into here, right? And then once we've copied, right, then we're going to our CMD, right? Basically just repeating like the steps. So I think this Docker commands, even if you use the small letters, they're basically, it's fine, but also for the sake of readability and like convention, everyone uses capital letter for specifying like this Docker commands. But basically you can say so node, you have this as array values. You can say index node index dot so what's this telling me? Provide default for an if. Alright, so yeah, that's fine. So yeah, that should be right. So this is why I like using VS Code, because like the Docker extension just helps you correct like certain things, right? All right. So the next thing we've done is we've written our very simple Docker file, right? So the next thing we have to do is we said Docker file is like a template for building Docker image, right? So we have to use this Docker file, right, to build an image, right? And that's the image that we can now run to start up. So that gives us a container, right? So how do we build this? So we'll say Docker build, right? And then we give it here to build the image, right? So now we're in the current directory. If we're somewhere else, we'd have to specify like another path, but the Docker file is in the current directory, so we'll do that. We'll put it back there. So this is where I want to talk about. Okay, let's build first. So yeah, I should have used Node 17, so we don't have to pull from Docker Hub. But basically, you see what happens is first Docker goes and pulls from like from Docker Hub, right? Pulls like the image from Docker Hub, and then pulling that image, and then builds like so you would kind of see like every step throughout the Docker file. So let's just watch. You can look at the terminal. Yeah, this is gonna take a while. Not sure if we want to wait for that. Yeah, but it's gonna take a while. Alright, so just for the sake, because I have Node 17 Alpine, yeah, I'm just gonna stop this so it doesn't take our time. Yeah. So now you see, because I have Node 17 locally, it didn't have to go download it all the way from Docker Hub, right? And you could see all like the steps in the Docker file, right? So you copied. So basically, what this thing means: copy everything that's in the current directory into a directory into the base directory in the container, and then this is a command is like what we have to run, right? So you can see all of that, all the all the stage, all the stages inside the and the Docker file. All right, so now this thing, the image has been built, right, with an ID of this, right? So we can say we can now do Docker run like this image ID, right? And this will run. It should run. I should run it for us. Yep. So this tells us server started on port 13. Now let's go back to call, right? So let's stop this, right? Let's try and call localhost, right? Now we have our app running on 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 ports on port 3000, right? We can do Docker PS to be sure like the container is running, right? Right, you can see, so there's the Redis container we started at the beginning, and there's this container, right? So we can basically, yep. So now let's try and call localhost 3000, and let's see what we get. We see we failed to connect. Why? The reason is because a container is isolated, right? So the networking, everything is in its own like sort of box, right? It's not accessible from the outside world. If we need anything from the container to be accessible from the outside world, we'll have to like kind of like specify that, right? So as you can see, we can't access like localhost 3000. All right, so we can also let's do something. Let's say Docker let's exec into this container, right? So let's exec into this container. So this is IT. Docker exec. I think the order of the commands need to be unable to. Okay. So just to be sure I have this correctly. Yeah. All right. So Docker exec intro. Let's just do this. All right. So now, if you see in the container, this is inside the container, right? So if you do, you see like this is different. This is on my PC. This is inside the PC of the container, right? So you can see like we can cut index.js. I hope Alpine Linux has cuts inside. We can cut, yeah. We can cut. You can see index.js, right? We can also see the Docker file, right? We can see the Docker file, right? We can see like the Docker file. All right. So you can see like this environment. This is a totally different environment from my PC, right? This is a container with its own like file system, with its own like mounted. The file system has been mounted afresh, like in its own separate environment. All right. So how then do we connect? How then do we allow like communication from the outside world into our container, right? So I don't know what the correct word is, if it is port forwarding or port mapping, but we basically have to take like the port in the container and map that port to the host, right? So it's for basically for all the resources our containers isolate, right? We need to find a way for them to be accessible by the host if we want to use them from the host, right? So for networking, the networking of the container, if we need it to be accessible from the host, then we would have to like we'll have to what's the word? Yeah, we'll have to basically find a way for it to be accessible from the host, and the way we will do that in here is by port forwarding. All right, so there's another Docker command we're gonna learn about now. There's a Docker. So I'm gonna take the container ID of our Node.js image, the thing we just the simple server we just built now, right? And then yep, I'm gonna kill it. I'm gonna say docker kill this image, right? Kill this container, sorry. All right, so you can either kill by the container ID or you can kill by the container name. So if you don't specify a name, it's given a name. So we can actually build this again afresh, and let me show you how you would build it with a name, right? So we can say a docker build, if I'm not mistaken. You give it a name. Yep, give it a name of let's say hello world. Let's call this node hello world, right? Docker build, yeah, if I'm not mistaken. Interesting. So docker build, I want to give it a name of, let's say a node hello world to be sure. Okay, docker, let me just look at the help. So docker build, that's yeah, there should be an option for a name when you're building it. Oh, okay, I think the name is when you would run in it. No, actually, you should be able to specify the name when you're building it. So let's see. Okay, that's not an option. Okay, interesting. All right, so I'm just gonna see. Just give me a minute to figure this out. All right, so I'm surprised this should be able to give a name. All right, so we can do. Well, basically, what I've done here is given it a tag. So I think you can make this. The long form is, you can give it a tag this way. The long form is a tag, right? Or you can shorten it to T, just a single quote and T. All right. So basically, right, we basically have so we can now docker run node hello world, right? And I think we can give it the name of we can give the container a name of node let's call this node app, right? So run, couldn't find node image, node hello world locally, docker images, So this is gonna be even hard to see. Node hello world. Oh, okay. Yeah, that's a typo for me. There should be node hello world. Alright. I should say docker run / help. Let's see. Yeah, you can give in a name to the container. Yep, you can give a name to the container. So I think docker run. Interesting. So I think the positions of these things matter. So I'll just call this node app and see. Oh, okay. Yeah, that worked. All right. So I'm just gonna do this docker remove node app. All right, I'm gonna do this again. Docker run node app. All right, so now we've been able to, if we go back and do docker ps, you can see we have an image of node of node hello world running, right? And we have a container with a name of node app. So we can just simply kill this container by saying docker kill node app, right? So this is how we'll kill like a running container. So if we do docker ps again, we won't see that container. All right. So now back to the example we were doing. So now let's run. So how do we make this node app? How do we make this our node app accessible to the outside world, right? The way we do this is by something called port publishing or port forwarding. So right, we can publish this port and say, I want you to map from the container ports, map port 3000 and the container port, right? Map that to my host 3000, right? And all right, so I think the order of these things really matter. Docker run, the name, node hub, the image, node app, I think has to be here. So I'm gonna call this publish port 3000. I'm not mistaken. Right, so docker remove, and I'm gonna show you. So basically, the reason why this thing here is happening is because when we create a container with this name, right? When we kill that container, right? Docker, so we can do something. So if you want to see the logs for a container, you can do something like this: docker logs, right? Node app, right? Docker logs node app, right? So this will give you like the logs on the app, right? So as you can see, like even though we killed like that container, everything about that container, if we do docker ps, we don't have a node app container running, right? But Docker still preserves like the logs from the app. So for us we have to like remove that. We have to remove that docker remove node app, and then we have to remove that, right? So, but there's a command we can pass, of course, that would remove this once we bring down a container, and we'll get to that like in a minute, right? So docker run. So we're gonna run this. So basically what we're doing is we are mapping like port 3000 in the container to port 3000 in the host, right? Because we have to create, since the container is isolated, right, we have to create like some sort of channel between like the container and like the host networking interface. All right, so we would run this and see. Right, so now let's try to call again, call localhost 3000. Right, now we get a response. Right, we can also in the browser we can also do localhost 3000 and we'll get a response, right? But this app is currently running inside the container. So if we do docker ps, we can actually see like node hello world is running inside the container. All right, so let's kill our node app. So this is another reason it's good to like name your container. So now it's very easy for you to kill this container because you gave it a name that you can easily remember. All right, so yeah, so that's basically how you will write like a basic Docker file, right? So let's extend this a bit and let's just make a very simple like a express application, right? Because we all know like this is not how you would put like an actual working. This is not what like a server a proper like Node.js app would be more complex than this, right? You wouldn't be using like the inbuilt HTTP module to like write the server and all of that. So let's make a very simple express app, right? So we would say let's npm init -y, so we don't have to go through all that shenanigans of npm. So and then npm I express, right? All right, so in here let's just call this server.js, right? So let's call this let's import express equals to require express, I think, right? And then let's make our app. So app would be an instance of express, right? And then we can say app.get. We can say app.get. So if you get, so this will take in request, response. We don't need the next function in this case, right? And then we can say response that I don't know. Let's just say that send. Let's just send hello world. All right. So I think we are, yeah, that should be it. We're not doing anything fancy. All right, so we're going to say app.listing. I think so listing will take in, I think, a port. So let's listen on port 3000 and takes in a callback, right? So we can say console.log server started on port 3000. All right, so now let's rewrite this this Docker file to basically to use our new express file. All right. So the very first thing here is now we have a package.json. We have a package.json file, right? All right. So we have a package.json file, and we also have a package.json file, and we also have a node modules folder, right? So the first thing is, do we really want to copy like our node modules folder into our Docker file, right? Do we also want to copy what do we want to copy and what don't we want to copy into our Docker file? So let's assume, like in this case, let's just copy everything, right? When we copy everything, right? We're gonna change this to server.js, right? And let's docker ps just to be sure, we don't have that container running. So let's build this image again, right? So we're gonna say docker build, give it a build, give it a tag of not docker build. Yeah. So we're gonna build this image all over again. All right. So let's say docker run. All right. So we have to do docker remove node app, right? First, and then docker run. So a way for you to avoid that is, I think you can pass in a -rm flag, if I'm not mistaken. I think it's -rm. It's -rm, right? So that basically frees up that name basically when we're done, right? So we have docker, we have a express file running again. So just to be sure I didn't save that file. So yeah, and then this is another weird thing again, is that this, for some reason, like the POSIX signals, right? They're not getting passed to like Node.js, right? We talked about like all the sigint and the rest, right? So we have to like kill this thing, right? So we have to docker ps, right? Node hello world. So we're just gonna docker kill node app. All right. So now we've killed a node app. So another way you can, I think you can avoid it is by parsing init, I think, right? Yeah, if you do this and then you do, this should kill it. If I'm not, yeah, this should work now. Or there's a script you can basically start up your Docker files with that would receive like the signals, the POSIX signal from Docker, and then pass them to your app. Alright, so just to be sure, because I'm not sure I built that image properly, I'm just gonna build it again. So we're gonna docker build docker build t. What did I call the image again? It's a hello docker build t. Docker build t. I think hello world. It's interesting. Can't remember the name of. Okay, yeah, node. That's the name of the image. So docker build t node hello world, and in the current context. All right. So we can then run this. We can run the image again. So we can say docker run, right? And yeah. Okay. So now we have our express. I could even be explicit about this and say express server started on the. All right. So if we go to localhost 3000, we get back hello world, right? Being served from our express, our simple express application, right? So, but there are a couple of issues that we have here, right? Right now, we're copying everything, including like the node modules, right? So imagine if I were using Windows right now, right? The build for Windows will be different, like the compiled whatever like node like gives us for Windows will be way different from like for Linux, right? And inside our container, it's Linux. So the reason this works seamlessly is because I'm using like Linux, right? But if I was using maybe like Windows, right, this would not work, right? The mod modules files that we're copying in here would not work. So what's the right thing for us to do? We just have to copy the things we copy what we need, right? So we have to copy our application source code and also copy we have to come here and then run npm install again, right? So we're going to run like npm install, right? Npm install, right? That would now install the files from our package.json, right? And then that's when we'll not have everything we need, right? So let's say let's uh, let's stop this. And let's build our image again. So there's another thing about like building Docker images I kind of want to touch a bit about is that so these images are built like in steps, right? So you see like previously, because if we repeated like the same command as before, right, Docker caches everything, right? So if we repeated like the same commands before again, it would just build like very straight up, right? But because now we've added something else, another layer is cached through. It's based on like layers and layers and layers, right? So in our case, you see every other thing here ran so fast until it came to npm install, and that's like the new thing in that layer, right? And that had to like run. All right. So we have a npm install, right? And then if we run our application again, right? And then everything works as expected. All right. So so the next thing I want to talk about is basically like is basically first it's basically how. So if we go, let's do a small experiment. So let's say docker exec, right? Let's just say let's call this, since it's called, the container name is called node app, right? If you see here, we're keeping our application source code in the base, in the base directory, in the home directory of the in the like the base directory of the container, right? We don't want to do that, right? We'll not put like keep it in a separate folder, right? So let's do this. So let's say instead we're gonna run like a make directory. So this is a command, like if you run this, it's a Linux command for creating like a directory. For example, if I say I don't know, make directory mk, make directory salvo, right? If we can then, if we check here in the list of folders, we will see a folder called salvo, right? And we can cd into, we can change direction into salvo, right? So it's the same, it's just basically the same commands we're going to be running here. So like let's make a directory called home, right? And then we call this, let's call this node, and then let's call this source, right? Just say this is where we keep our application source code, right? And then the next thing we're going to do is we're going to call this thing our work directory, right? So we're going to say our work directory is going to be home, right? Node and source, right? All right, so the reason is we're doing this, so now what we're telling Docker is this is our working directory, so everything that you're doing, do it in this directory, right? So let's build this image again. So we can just docker kill, let's kill the container, docker kill node app. Okay, the container is already dead. All right, so let's build this container again. So let's run the image. Start up our container. Right. So we can exec into the container again, and if we do ls, right, you see this becomes our working directory, right? So we're now working with node, home, node, and source, right? So everything related to our application, now we keep it one place inside the container. All right. So there's another best practice around container is that, so by default in Linux, right, this is a Linux thing. By default, if I do who am I right now, right, this, how do you list users again? Then list list users in Linux. Nope. It's a very to list all the available users. No, not my LinkedIn. Right. Can't remember the command off the top of my head right now. There's a way shorter command. All right, but the default, so by default, right, you are executing things as root, right, in the container, and like a root user has like elevated privileges, right? But that's not what you want to do, right? So you want to so if we're inside the command, right? If we do who am I now, who am I inside here, it says root, right? If I go to my PC and I do who am I, right, it will tell you that it's error, right? So if I want to run like a user, I have to maybe like change my user, right? I think not what? How do you change your user again? I have to change my user to like maybe a root user, or I have to use like the sudo command to run something as root, right? So it's the same thing that applies here, right? So you have to like use like a different you have to use like a user. So by default, this Node.js images all come with a user called node, right? So if I could find a way to list the users, I could just list like the users inside the container, and you'll see like there's a user called node, right? So now you can, I just don't want to go through, like I would probably Google like the command later and send it to you guys. But basically you can have like a user, you can basically specify and tell Docker, okay, use this user called node, right? This is a user I want you to run to use while like running our application. All right. So once you've done use this, now we don't want to copy. We just don't want to copy everything, right? We just don't want to copy everything into. When we copy, all right. So when we copy, right? Actually, I want to show you something. So this is I'm just gonna kill that container. So I'm gonna say docker kill node app. That should kill our node app for us. All right. So and I'm gonna rebuild this image again. We should run into an error, and I'm gonna talk about that in a minute. Oh, okay, that worked. Interesting. Yeah, that's not supposed to work. Exactly. So the reason we're getting this error, and if you use Docker, and especially if you change like if you use like a different user, right, you would run into permissions issues a lot. So it's something you should be prepared to deal with. So why is this happening? Basically, this is happening because we don't have permissions. Um, we don't have permissions to basically. So if you look at the steps in the container, right, we got to npm install, and then npm install tried to fail because npm install is trying. When you do npm install like creates like a node modules folder, right? So we are trying to write to this directory, right? But we're user node and we don't own like this directory, right? We're trying to write to this directory. So basically, what the solution basically to this is basically using this Linux command called. So you also have to get familiar with this, right? So you can change like the ownership of basically of something, right? So of a file or a directory, right? You can read more about it and see how it works. Or basically in Docker, so we now say something like this: churn or change ownership, right? Or change owner, I don't know. So basically we have to change like the user and the group. So conveniently, we have a user called node, right? And we have a group called node, and we have a user called node, right? And this is something that's already pre-programmed by the because of the Docker image we're using, right? So it's not something that comes with all containers, right? So we can then let's build our image again. Right, so you see, because we previously ran every step up to here, right? So Docker just simply started from here, right? Every other thing, every other one used the cache. Every other step used the cache, right? All right, so now that worked, right? And we can easily run our app, and everything will work, and everything will work perfectly. All right. So the next thing I want to talk about is, so there's another option called npm CI. I think yeah, it's called npm clean install, right? So basically, npm clean install uses what's in your package.json, package lock.json, right? So it pins to very specific dependency, right, in your package log.json, right? So the reason you want to do that is you want to be able to reproduce. The reason people use that is because they want to, like, you want like the exact same dependencies you are developing with. That's what you want to be in your container, right? You don't want like the issue of okay, it works on my PC, but like in the process of like npm I, like I got like an upgraded version of the dependency or something like that. All right, so we can replace this with npm CI. We can replace this with npm CI, and yeah, that should work. That should yeah, that would pin like to a very specific dependency for us. All right. So the next thing I want to talk about is basically a small optimization we can make, right, to make our lives like a bit easier. So in this case, or in our case now, let me kill this thing, just docker kill, just in case it's not dead. It's probably dead. Docker kill node app. All right. So let's try building this image again. Right, a better way, because if you think of this logically, right? So everything is broken down into steps, right? So we can do something like this. We can just copy only our, what's it called, our, we can copy in each step. Node, let's call this node, let's call this our node, right? Let's copy churn node, right? We want to copy our package package.json, and our package lock.json, right? And we want to copy that into the current directory, right? And then we also want to copy every other thing else, right? And then we run like npm ci. So there's something called a docker ignore. It's similar to a git ignore, so it just goes with the docker ignore, right? So so basically it's similar to like a git ignore, right? So if you've written git ignore files, this is very similar to that, right? So everything you don't want to be in your Docker files, you put them in here, right? So let's see, we also want to exclude index.js, so we're just going to put index.js, right? Because that's the alright. So did I kill the container? Just to be sure. Yeah, I did. So let's build this image all over again. Then we can exec into so this Arch thing, yeah, being Arch, so if this was Ubuntu or any Debian based distribution that used Bash, this will be Bash, but because we're using Alpine, so this is just a shell for Alpine Linux. Alright, so we're just gonna exec into okay, we're still yet to run the container, so let's just start the container. We can exec into this, and you can see now all the files we ignored, it's and the Docker files, we didn't see them there, right? But this node modules is not the one from us, it's the one that the npm CI installed for us. Alright, so I think in a nutshell, let me look at my notes. I think I've covered everything I needed to cover today. So the next thing, so another syntax you would see often is this thing called expose. So you can expose like a specific port, right? So you can expose like a specific port, right? So if you expose like a specific port, right, it still doesn't do anything until I think you need to pass a flag called, I think, capital P, if I'm not mistaken, capital P into Docker. So let's do this. Let's take out publish, right? If you pass in capital P, now Docker will just assign like a random port to this. So if we do a Docker PS, you'll see a Docker node app. Okay, we have to like build the image again. So we'll say Docker kill node app, and then let's just So now we can run this. I think with a capital P flag, and Docker will just assign us a random port. So I think if I do Docker PS up, 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 node hello world, right? So yeah, so Docker assigned us a random port of copy. So if I go to my browser and I call and I just localhost this, so we should get hello world. All right, so I'm just gonna kill that. So in most cases that's not what you want, right? You want to be able to like know this forward to like a specific port. So I would advise you continue using like the other option. All right, so the couple of other things I would not cover in this video. So there's basically so everything that's the file system in a container is isolated, right? So if we need to be able to access like the host file system from inside the container, we need to do some sort of we need to do some sort of we need to find a way to link to make them interact, right? So Docker volumes. So Docker volumes are basically the way you would achieve that, right? Allowing like the host basically, so this is like Docker bind mounts, right? That's a way like you can allow like the host file system to be accessible from like the container. And then there's also a Docker volumes that way like the file system is managed by Docker. That's like the difference between the two of them. So I'm not gonna go in depth into that. I'm just gonna I'm gonna leave that to you guys to go and figure out like how that works. And then yeah, so there's also another thing. So if I do let's just talk about networking a bit in Docker, right? So if I do Docker network ls, right? I have other network here, but usually if you do yours, if you've not created like a network before, you would see that this bridge, I think the host and none, right? So these are like the three network you would see, right? So networking is basically, like I said, like the network in a container is isolated, right? So usually Docker would advise that you create your own so I'm just gonna call this Docker networks. Docker would advise that you create your own network, right, rather than using the default bridge network. So for example, I'm just gonna show you something. So if we start up this container, right, and I do Docker inspect network, and I inspect the default bridge network, right? So I'm just gonna inspect the bridge network, and you'll see like this our container, the node app container, you can see from here is running inside like inside the default bridge network, right? So by default, when you start the container, if you don't specify like the network, it runs like on the default bridge network. All right, so you can create your own network. So we can do docker kill node app. Let's create a network now. We can do Docker network create, let's call this appnet, right? Docker network create appnet. All right, so now we can now start up our container, right? We can start up our container. This time let's put the for that publish, the short form is P, right? Just P without like the double hyphen. All right, so we can then use specify a network of net, right? And I always like mixing up this appnet. All right. So now we can inspect our AppNet network, right? So we can just inspect AppNet, and we'll see in the containers we have our app running inside the AppNet network now, right? So if we have another, so a network is sort of like isolated. It's a virtual network, right? So it's isolated from the host network, right? I don't want to. It's a Linux thing, like some. So think of this would be like a proper network, right? So with a switch and all of that. I don't want to go into the details of how this works, right? I also don't know a lot about this. Networking is genuinely one of the hardest part of computer science, and I'm still learning. Networking, but yeah, that that. Yeah, that's basically it about Docker networks. So you can create a what's it called, multiple containers inside the network, and as long as containers are in the same networks, they would be able to communicate to each other, right? And they will be able to communicate to each other. I think using like this, like if I'm not mistaken, the name of the container can then be used as a DNS name. A DNS record is created for like that container. So you can simply refer, as long as they're in the same network, you can simply refer to like maybe like the node app container by its name, and that node app so so if I ping if I'm not mistaken, node app, yeah, from inside the container, if I do this, so actually we can okay, let's not dive into like the networking parts, but if you start up another container right in the same network, if you ping this node app will resolve to like the IP address of this container. All right, so there's like a Docker networking is like it's like a whole thing on its own. So if you can dig more into the documentation if you are interested. So there's like bridge networks, overlay networks, and yeah, on all of the stuff. Okay, so the next thing I'm going to talk about is Docker Compose, right? So Docker Compose is this thing used for running like multi-container projects, right? So let's go back to our other project that we're working with, right? So so we can solve it. So solve it, our library API project, right? So in this project, we are depending on a couple of things, right? So if I cut our .env, right, we're depending on MongoDB, we're depending on what else? We're depending on Redis and the likes. Right, so actually, let me just create a new branch. So git checkout v Docker, git checkout v Docker. All right, so Docker Compose is mostly used for like provisioning like your dev environment. It's very good for that stuff. I've provisioned like a production environment also before with Docker Compose, but the most use case for Docker Compose is always like provisioning like a dev environment, right? So if you rely on like Redis, you rely on like so many things, right? This just it makes it easier for like your application, right? It just makes it easier for you to start up like all the resources you need. So let's just open our API project. All right, so I'm gonna close like the previous one. So just because all right. So we can have a Docker Compose. So Docker Compose .yaml or .yml is the same thing, right? So every Docker Compose file, it's all a YAML file. So YAML is just like Google what YAML is for you. I think we've talked about this, right? It's sort of like a, what's the word? Yeah, a data serialization language, right? So just like JSON, right? It's a serialization. It's basically a serialization language, right? Just like JSON, and I think what's the other one? I think yeah. So YAML is a serialization language, so it works across, like it's not like language, just like the way JSON is not language specific, right? So also different systems can interact with each other. All right, so basically you use Docker Compose for like starting multiple projects, right? So in our case, you would just say, let's say in here, right? So services, I'm just gonna say Mongo, and Mongo. I think the image, you can say the image is what I think Mongo. I'm not sure. And then the ports, and then the port is what's the MongoDB default port again? 27017, right? We're gonna map that to 27017, right? So the next thing our application depends on, right? In this case, in our case, is what the image is. What is I think Redis, and then the ports is I think 63. What's the Redis port again? Redis CLI. Yeah, 6379. 6379 6379. Right. So this is the same. This is the same. This is the same format as our. So this is like the port on the host, and then the port on the container. The port on the host, and then the port on the container. All right. So let's see the next thing. Let's call this our backend, right? So our backend is where. So we'll just say the build, and I think the context. The context is here. I think this is the context, if I'm not mistaken. Yeah, yeah, the context is here. So I think you can also refer it directly to like the Docker file here, but I think this should be all of it. So your assignment for today will be like find a way to load your environment variables into how do you use it's your research, go and research how do you use like your environment variables like in a containerized like environment like Docker Compose. All right, so I'm not gonna Dockerize like the app itself. What I'm gonna Dockerize is basically how you would spin up like your development environment. So let me be sure like the name of the image is called Mongo. It's like Mongo or MongoDB. Oh, okay, yeah, it's called Mongo. All right, so I'm not gonna pin like a specific version. All right, so I'm just gonna do this. Also, yeah. So the reason I'm doing this is so that in our configuration, we'll be forced to use like the default. We'll be forced to use like the default MongoDB URI. Or I can actually do this. I can just say Mongo. So we'll just say Mongo URI equals to, I think, what's the scheme again? That MongoDB scheme. It's what MongoDB localhost. MongoDB localhost. Okay, yeah, it's MongoDB localhost, if I'm not mistaken. MongoDB localhost. 27.0.17. All right. So I don't want the container, so I just to be sure I want to kill like the sudo, so just service. I think this is Mongo, not stop. Just stop. I just want to kill my own Mongo server. I think if I'm not mistaken, what's the? I can't remember the name again. System. All right. So just for the sake of, I'm just gonna give this a separate port, right? Just so it doesn't clash with my local MongoDB installation. All right. So now with Docker Compose, right? So what happens with Docker Compose is you can do like a Docker Compose, right? You can do you can do a Docker Compose build, and it will automatically find the Docker Compose in the current directory, right, and build up your containers, right? So for the first time, if you do Docker Compose run for the first time, it would build the containers for you. So I think Docker Compose build Docker, just to be sure I have Docker Compose installed. Alright. So Docker Compose build. Alright, so Docker Compose. So we don't need to build these images because Docker will the images are not available locally, right? All right, so as you can see, so if we go back and do Docker PS, right? So we have Mongo and Redis, all started by Docker Compose. All right, and also another thing about Docker Compose is Docker Compose creates a network, a default network that starts with the folder name, right? So there's a default network created by Docker Compose where it runs all your services. So all of this now run in the same network. So we can actually do this. We can do a Docker PS, right? So we can the name. Okay, we can just take the container ID. Just do this Docker exec. I'm not sure if I think the Mongo image is built on it's not built with Ubuntu, it's built with one of the Red Hat distros, so Bash would not work. But essentially I wanted to show you that because they're in the same network, like the names, you can refer to the containers by names and it will resolve to like that container. Anyway, so what else? What else again? What else? So that's basically how you would use Docker Compose. So it's left to you, dig into the documentation and see how you would use Docker Compose for like more extensive use cases. So the last thing I want to talk about is basically how would you provision like your test environments with Docker Compose, right? So remember when we were testing, we wanted to be able to use like an actual database, right? but at the same time we don't want to use like the same the database we're working with, right? We want to use like a different database. So with Docker Compose, right? So we can also do this called Docker Compose. We can start up a container, right? If we do Docker Compose D, it will start up like these things, but in the background, right? There's the background and the foreground. So we can also do Docker Compose. We can do Docker Compose down, right? Or we can also do Docker Compose top. Docker Compose down will tear down everything and everything that's being used and remove like the network. All right. So the last thing I want to talk about is how we would provision our test environments with Docker Compose, right? So in the package.json files, right, we have like the script, right? So we can say something like this, right? We can say so in your package.json file, right, npm has this concept where if you attach, if you put a pre to a specific command, right, npm will run that command before. So for example, we can say something like pretest, right, what we want npm to do. So in here we can now do Docker compose up, right, pretest, and then once we're done running our test, post test, right, post test, right, we want to say Docker compose down, right? So that this way, anytime if we run npm run test, right, if we run npm run test, right, you can actually, we're gonna say this, you would see, so Docker compose will first run and start up like we can actually, so let's do this. So I want to start this in the background, right? So we'll do this. So it starts everything in the background so we can actually see the results from the test. All right. So now this way we can now use, in our test we can use like the database and the Redis from the test, right? Instead of using like an actual database or a mock database. And then when the test is done running, Docker will kill, like Docker Compose will kill like this. So if we do like this, right, when the test is done running, Docker Compose, you see, as we stopped the test, Docker Compose, this post test script runs and brings down all the containers. So I'm gonna push this to so I'm just gonna push this to the repo. You guys can have a look and clean it up and make it look nice and add like a lot of other edge cases. So I'm just gonna say add Docker compose and test examples. All right, it's a long day and I wanna go do something else. So I'll see you guys next time. All right, so git push origin Docker. So yeah, that's basically all you need to know about Docker from like a developer perspective on how to work with Docker. So you would have to like practice more and all of that. But yeah, from a developer perspective, that's what you need to know. All right. I will see you guys around.